Sure.
You start with a DT matrix,
Okay.
two-dimensional reduction. Let's say you remove 4 dimensions. And let's take the example which you did in class. So out of 6, you remove 4 dimensions and you left with 2 dimensions. And you multiply all the 3 matrices and you get a new matrix which is more similar to the original matrix.
Yeah, but you don't need to multiply it all the way down.
No, just coming to...
It just so happens that if you were to do that, that would be the closest approximation to the original DT matrix that happens to have rank 2.
Right. Okay, so let's say that as a user, I don't know what's the amount of noise present.
You don't, yeah, that's not given. So
my question is that, can we do one more step of SVD on the new matrix which we get, and
how does it matter?
Do we achieve something because if we do one more filtering on?
No. Basically, you can get, if you want to decide how much noise to reduce, you always do it just with the given matrix itself. So, so you have essentially, by the way, these are called singular values because they are the positive square roots of eigenvalues. They are called singular values. Okay. So if I want to just keep 2 dimensions, I will keep lambda 1 and lambda 2 and 0 out everything else. If I want to keep 3, I'll keep 3 and 0 out everything else. So I can get all possible reductions of dimensionality of the data just from here. Now as to what is the right level of reduction, I don't know. Basically, for example, what's the right level of noise reduction for your music? Especially the kind that comes on shortwave radio, which none of you anymore know. Okay, so if you are getting, radio transmission, then there is noise, and you can try to start reducing noise. If you have some kind of a bandpass filter, at some point of time, you are also losing signal, especially if it's high frequency signal.
So going in the play of words, which you give example, we have UV and we construct W. Let's say 2U plus 3V is a new term W, which we have, and we do LSI on that and we get back UV. And how do you know that UV is not again composed of something else, which is...
No, all that matters. First of all I'm saying is LSI gives you an orthonormal basis, that's it. Okay? Among multiple orthonormal bases, there is not much, so this is the orthonormal basis that also reduces, that also captures the variance, such that the first axis has the maximum variance, second axis has the next maximum variance, etc. You can never be sure exactly what the original dimensions, original basis was supposed to be. It's just that it captures, if in fact the original basis was linearly corrupted, then you are likely to get back the original basis by doing this. And the best way to play with this, essentially, how many of you have run an SVD on a matrix after this class? Before this class? Okay, you really need to do it. That's one way you can get, you can check some of these things. So for example, make a matrix, which is U plus V, etc. We start with a matrix, make a new matrix with your specific way of linear corruption, and run SVD on it to see if in fact it is capturing the original basis. So I took you through multiple stages of corruption. You could play that essentially. SVD applets are dime a dozen. If you have MATLAB, you can run it anywhere. But if you don't, you can just call, search for SVD applet. And there are many SVD applets out there, and so you can always enter your matrix and figure that out. Okay. And the other interesting thing is you will never know how much is the noise and how much is not the noise, by the way. You'll never know that because essentially sometimes actually one man's noise is another man's signal. Because of what reason? Because of, for example, have you heard of steganography? What is steganography? It's essentially I'm putting a signal in an image, okay? And essentially, it's an image that everybody is looking at. What I'm interested in is actually this additional noise that I threw in. Okay? And steganography is basically, if you remove too much noise, then you lost the information as far as I'm concerned. So you, again, in terms of dimensionality reduction, it sort of makes sense most of the time, but I can always be an adversary for you. And knowing that you're going to do this kind of dimensionality reduction, I can put all the relevant information in the high dimensions, for example. So, but for most normal scenarios, if you remove the high variance, low variance dimensions, you don't lose. At least you don't lose variance. That's basically what you don't lose. Any other questions? I did send the homework problems, so you should start being able to look at them, and then if you get stuck, maybe that's when you can start asking for questions. Okay. Okay. So there are no questions on this stuff. I mean, basically my assumption is that if you're not going to do LSI, I will then go to the next step, which is information retrieval on web pages. Basically, which is we are done with the traditional information retrieval. We are now going to actually start talking about how to use that stuff on the web. I know that you didn't really believe me when I was saying traditional information retrieval. You're only thinking of web. But really what we talked about is traditional information retrieval. And then we can start talking about how it would be changing if you have the constraints of the web. Okay? There was a raised hand, yes.
In the sample which we showed, we could separate out the table. The samples could be separated out to two groups. So we got two dimensions.
No. The dimensions will always, if we kept two dimensions, we get two dimensions. It just so happened that in this case, the data happened to just nicely be spread out on one axis and the other axis. That was just the way it happened. It's not going to happen all the time. So for example, you will always be able to reduce dimensions to two dimensions. You will always be able to do that. But that doesn't necessarily mean that the data would nicely arrange itself in those axes. Okay, if I gave you data such that in fact it sort of was, so in the fish data, remember the fish picture? Okay, if in fact I gave you circular fish data, that means I got enough fish such that essentially if I plot the length and the width, I'm getting a nice big circle. Okay, then there will still be a major axis and a minor axis, but they will be basically equal in size. So in that case, reducing dimensionality didn't buy you anything because the data really is truly two-dimensional to some extent. Actually, it's kind of an interesting question. If I have fish data, which is sort of like this, right? Then our kind of approach basically would probably find that as the axis, but I can also find this as the axis. Any of them are axes. And they'll all be equal sized axes. And in particular, remember the word eigengap we talked about?
Will be 0.
Eigengap will be 0. That's in general, bad data is one which is eigengap is 0. That means its true dimensionality is actually whatever you're showing. So reducing dimensionality there means you are actually cutting off, a limb or two, in essence. Okay. So in this kind of a case, essentially, you will still be able to reduce dimensionality. It's just that it's no better this way than before. In the previous case, you could have just reduced either this axis or this axis. Okay. But now you will either reduce this or this, remove this or this, and it's just as bad. You see what I'm saying? Whereas had the data had like an ellipsoidal structure, then in fact doing reduction of dimensionality in this spaces would have given you a better idea of which is the most important axis, which is the next most important axis, and so on. Okay? Yes?
If we do the LSI, the whole point is to do dimensionality reduction. Otherwise, if you...
Yeah, if in fact the data has it has lower dimensionality than, effective dimensionality, then LSI will let you capture it. Now, this is not one fact. One important issue. One important issue is that LSI is really only for linear dimensionality reduction. Okay, it's a huge issue. I mentioned this earlier too. That if your data is like, let's say, in a three-dimensional space, let's say, okay, in a three-dimensional space, your data is laid over on the surface of a sphere, that's it. Or maybe just on the circumference of a circle in the three-dimensional space. Now clearly it's clearly not three-dimensional now. Okay, but LSI would not necessarily be able to find that out because the new dimensions are nonlinear combinations of the old dimensions. And when you start doing nonlinear dimensional reduction, then you will be able to capture it. That's much costlier. You know, if you're complaining that LSI takes n cube time, then it's much worse for nonlinear dimensional reduction. We don't even touch it. Okay. Yes.
What does latent signify in LSI?
Latent essentially means that the original dimensions of this fish data, you threw the fish data this way, right? But really the original dimensions are supposed to be that. And I didn't tell you, I told you length and width are the dimensions, but really you figured out that this funny axis and this other funny axis are the true dimensions of the data. So latent means hidden dimensions of the data. Yes?
Let's say we have a data for which we do the LSI and see that we have only 2 eigenvalues and we cannot afford to cut off one eigenvalue because then it would be on one dimension. So LSI, what it actually does is it captures a correlation also. So in that case, can we look at it as something that we are not getting rid of a dimension, but we are capturing the correlation components? Is it true?
First of all, let's be serious. It's very, very unlikely that you will have practically a document term data which has 2 dimensions.
So it goes to the problem which you gave.
I'm not answering my homework problems, okay? But in general, data will never have 2 dimensions in document term matrix, okay? So I'm not quite sure what that means in terms of, the extreme case you're pointing out is, I'm not quite sure what to make of it. Maybe you can ask me offline. Any other general questions? Yes?
Sir, so basically you're reducing the dimensions here only to capture the variance.
You're reducing the dimensions here because in effect it captures what? It captures a whole bunch of things. It's like here. Basically, in doing the dimensional reduction, you can then do noise reduction, okay? And you can also essentially exploit the redundancy. For example, 2 terms mean the same thing, okay? And so in some sense, what it's trying to capture is, it's giving up on that idea that the original space of terms are truly independent. They're not orthogonal really, so they have correlations. So it is in fact able to define each term in terms of the other terms. In fact, the factors, the latent dimensions are defined in terms of the existing terms. And then in that space, each of the original terms is a vector. So if you want to really say that 2 terms are very close to each other, then essentially the term vectors of those terms in the factor space would be very close to each other. So in fact, you can, I think that's what somebody's question, who was the guy who sent me this question about misspelling issue? Yeah, so if you were to misspell, there is a consistent misspelling of a word, then perhaps that word will pretty much occur in the same kind of a context with respect to other words than the non-misspelled word. So the effective vector for these 2 terms in the factor space would be the same. That's a way you could have found it out. That's, so that's one way of thinking about it. Okay.
So closeness does not relate to the meaning of two words, right?
What?
Closeness does not...
Close means that they are basically occurring in the same place with respect to other words. So you could replace one with the other, more or less. But does that make everybody happy in terms of not changing meaning at all? That's not what I'm saying. It's just, so for example, so computer and science are sort of connected, because they're occurring all the time together. Okay, so that's something that would be captured. Okay, so doesn't necessarily mean, it means essentially that if you have computer, then effectively you have some instances of science lurking there. But if I just take a particular topic, a particular document and remove all the instances of computer and just put science there, it does change something, in terms of the meaning. But its statistical properties are not changing, that's all you're saying. It's sort of true even in thesaurus, right? I mean, if you are trying to look at a particular word and you don't want to write this word, but you want to write some other word that's close in meaning, if it's a foreign language for you, you assume that the entire thesaurus words are equivalence class. But they're not equivalence class. Okay, loquacious, garrulous, and GRE training. Okay? Loquacious and garrulous. Would you like to say that my girlfriend is loquacious or she is garrulous? I mean, one way you'll have the girlfriend, the other way you won't. Okay? And they are part of the thesaurus. They're both very closely related, but they have connotations. Garrulous is putting down people. Loquacious is, for the same thing, you're kind of admiring them. It's a second order, third order effect, and you can miss that, in a thesaurus. Okay? Yes?
So because we're looking at the factors based on the terms, relations, then Bush and Saddam would have similar factors in factors?
It depends. Again, notice that I am not the guy who is saying this. In the document corpus, Bush and Saddam, in that particular homework problem, are occurring in very similar circumstances. And so you sort of infer, so it turns out that they'll become close to each other in the vector space, in the factor space. So that if you're looking for Bush, you might be looking, you might be able to say that maybe, here are some pages which mention Saddam but don't mention Bush, but you might be interested anyway. So the idea then is, when you wrote like a keyword, perhaps you just wrote one keyword, you could have written other keywords to elaborate your query. And you can use these additional correlated words to elaborate the query. Now what LSI is doing is it's just elaborating it itself without even asking you. Okay? Other questions? Yes?
Selecting the top K dimensions. I think in your last lecture you explained that selecting the top K might not exactly give you, what you're looking for. I mean, there was a explanation that you gave that there is a way of selecting which.
No, there is no way. It's basically the dimensions are, the eigenvalues, the singular values are, in the diagonal form from the largest to the smallest. You pick a K and you take the first K. You don't take the middle K. That's like bandpass filtering. It's not well defined for LSI. When we are talking about dimensional reduction, we're just taking the top K dimensions. Where top is, this is top. This is the top to bottom. Any other questions? Yes?
Is negative correlation
That's actually a very good question. Not directly. Not directly. Because what's not there is not there. Okay, so that was one of the motivation examples I did use before, but I don't believe that, I don't think you can capture that well. Okay, if you happen to have a finite size vocabulary, and when a then what you can do is, for every word that is occurring, so for each vocabulary word, you can write both yes version of the word and no version of the word. Okay, then you have compiled the documents into a new space. Okay, where there's a yes and no versions of each word. Then you can capture. negative correlation. So for example, you may be able to capture computer never seems to go with structure, for example. Let's say. But you can't do this here because you do not have correlations for words that are not present. That's a very good point, actually. Those are the kind of things that you want to think of, pushing it forward. You may not, there are levels of understanding for anything, right? Understanding to do homework and pass the exam and get out, and understanding which will make you, recheck everything I told you and figure out that I'm actually making up most of the things. And that's important. Anyway, so I am going to yeah, so Eric Schmidt basically apparently is now of the opinion that Google is a rational business. He's not sure that Google is a rational business trying to maximize its own profit. So those of you who are trying to look for jobs in Google, think again. Apparently this company is not interested in making profits. Why would the former CEO of a company say that? Because they want to say we are not a monopoly. We're just a little guy in the room. In fact, somebody was pointing out that when Microsoft was in the same exact position some years back, they too said, we're just a little office software company. What is all this nonsense about monopoly? We are not monopoly. Okay, so I think in particular, somebody asked a question to Eric Schmidt, that the congressman asked a question that, how is it really possible for a search engine to be both an impartial search engine and still own private search properties where it's only human, it's only rational to be tempted to point to them. And then Eric had to say, we are not rational people. We don't do that. Basically, he has to say we'll never do it, and so this is his best way. That apparently they don't do it at all. Okay. So of course, I thought you're right. Because in fact, pretty much that's the whole complaint about the competitors from the Google side that those things might be coming out.
At the same time, they have no way to prove because it's a black box.
No. But what they do is a black box. But what is shown is not a black box. Algorithm can be a black box, but the behavior is not, right? When you see the search engines and consistently you find, for example, like, I should be not saying this because Google gave me grants, but okay, don't listen to this. But consistently, if you start finding that Zagat is coming above Yelp, starting day after tomorrow, after the congressional testimony is over, then you still believe it's just Zagat just became popular, then I do have a bridge in Brooklyn I want to sell. Okay, and then you can buy it from me. Yes.
The point is they have a legal way of presenting the returns. It's just the opinion. That's how they protect Google, protecting their search results as being a statement of opinion, not necessarily just direct crash.
No, this is what he said. I'm not sure what your point is.
I'm like reading an article in the Wall Street Journal, and this is how they're trying to defend.
Yes, that's the whole point. That's why it's funny, because they had to go out of their way to say that probably we are not rational, and we would not ever do this kind of a bad thing, such as actually. It's a very interesting. The whole interesting. It's not economics class, but there are sections of the society, including professors, who think AT&T should not have been broken down. When Bell Labs was there, some of the best research in the world came from Bell Labs. Okay, it's true that some of these people here paid lots and lots of money for their phone calls, but man, it's good, for professors. They could go, spend time in Bell Labs, and monopolies are kind of good, kind of bad. Okay. So I'm not talking about that issue. It is interesting, however, that Google is, that Eric Schmidt thought, he's not sure that Google is a rational agent. Anyway, so what I'm going to do today basically is shift to IR on the web. So I can just stop with this one single slide, that a search engine is essentially a text retrieval system for web pages plus a web interface, and be done with it. So everything you said, you already did IR. Now, you just happen to have the whole thing on the web interface. So I could stop right here. So what do I miss? Okay. So what's new really, other than this? That's what we're going to focus on. So some of the things that are different on the web compared to traditional IR, which was sort of meant for, let's say, IR over previous law cases, or IR over library books, etc. That's where IR was originally making its mark. So the web pages are, some of the differences are, like unlike, libraries and law cases, web pages are very, humongous number of web pages. They're quite diversified. It's not at all on a single topic, or even a few topics. They're widely distributed on many servers. First of all, in a library, all the things are at least in library catalogs. These are all over the place. And they are extremely dynamic and volatile. So a book, after you publish, unpublishing it is not all that easy. Remember that guy who made up his entire life story, 1,000 little pieces or something, and he invented his own life and wrote a memoir, and it went up Oprah's book list, etc., etc., and then they found that he made up this whole entire thing. If that book can be bought still in Amazon, as far as I can tell. You can't unpublish a book. Whereas, if you don't want, at least in the beginnings of the web, if I didn't want my page to be seen, I just remove it. Of course, that's also going away now because Google will keep a cache of my page. Okay, but that's a different story. So in general, pages can come and go. So they're dynamically generated and they're coming and going. And what was there in the page before may not be there when you go back, which basically means it's a non-static scenario, which is not the case for IR. And then the next one set of things is actually, so what that basically means, this set of things, the challenge that these guys are giving you in some sense, is you need to crawl and maintain the index. You still want to use inverted index, just like we talked about before. But previously, inverted index, essentially all the books were in the library. You just basically poured all the words in one place, and say these words came from this book, these words came from this book, and you could reconstruct the inverted index. Now, the pages are on different servers, and so you have to actually go to all these servers and get the pages and index them. So the whole point of crawling is a big deal on the web. It wasn't an issue for us before. Okay? And then of course you have to maintain the index. For example, the index can keep changing. Part of the volatility issue is what was present on this page yesterday is no longer present today, and what was not present yesterday is present today. And so the index has to be continually maintained. Okay. In fact, one issue, of course, is how do you do this efficiently? Is a very big question because web is vast, and are you going to just re-index the entire web every so many days, or do you want to just incrementally keep re-indexing? And if you keep re-indexing incrementally, do you use the same frequency for all the servers, or do you use higher frequency for some servers and lower frequency for other servers? And if you want to use a prioritized crawling, then what would be your metric for priority? All these problems just came out of, from just the fact that, we're on the web. Okay. That's something. So we will learn about crawling and maintaining indexes. The other issue is web pages have, this is actually this is a plus point, they have more structure. So, if they're HTML pages, for example, HTML has structure in the sense that, you have header tag, you have, footnote tag, and you can even have hidden tag, and all sorts of, so basically you're able to tell not just a flat text, but it is text with structure. Okay? And so you can use those tags. And furthermore, pages are linked. Books are linked too. The footnoting is how books talk to each other. If you are a historian and you read a history book, and then, basically you're getting your source from some other book, and then so anytime you say something, you have to actually put a footnote for that book. So books are linked too. But following those links is pretty hard. You have to do it. Whereas in the case of web pages, it's just very easy because the hyperlink structure is, after all, just the cornerstone of web. Okay? So we could ask ourselves, first of all, how can we exploit this? Okay? One of the interesting things is that the link structure is used in books too, except there would be paid services who would, for example, read these books and those books and say, well, this particular book seems to be referenced by many, many people in other books. And those kinds of books in classical libraries will be put in the reference section. Right? And if you write a paper and other people are citing your paper, then there is this private organization called Science Citation Index Service who would charge libraries an arm and a leg and will send every 6 months or something. Okay, here is the current list of citations for each of the papers in the world. And then, of course, then the library can look at how many papers of Rao has been cited in the last 6 months and decide whether to pay Rao or not. Okay? So this sort of stuff is done. They are following links, except they are following implicit links, and they were using humans rather than computers to do this. Okay? So now it actually we can easily make computational. It's very computationally quite easy to follow these links, and so we can decide what to do with them. Of course, pages can also have additional metadata apart from just the tags, and you can use the metadata too. So now that basically means this is kind of an extra challenge. This is sort of an extra opportunity. So you can use the links and tags and metadata to improve the retrieval, make it more relevant, improve the precision, improve the recall. Okay. Then the third thing is, web search is noisy. Pages with high similarity to query may still differ in their relevance. Okay. Just because the query terms are present in the page doesn't necessarily mean two pages having the query terms are equally good. Two library books having the query terms might be closer to each other than two web pages having the query terms. In particular, it takes at least some time for people to figure, when they realize, for example, that there is this particular program that everybody is using, and so you need to write. They may be searching for how to, a manual on that program. So the Dummies Guide people will actually realize this and write very quickly a book called Dummies Guide to Program X, and then they will get an ISBN number, they'll put it in the library. It'll take some time. Whereas if I can just be following the accesses on the web and then see that some particular terms seem to be getting searched for more often than other terms just in the last 3 minutes. So I'll just make a web page up right now with those terms on my web page. And then more people will likely to come to this page. And of course, then I can get some advertisement dollars or something. Okay, so that's actually connected to the fact that web, as I mentioned long back, you know already anyway, it's uncurated and adversarial. Okay, you can make up pages. I can make a page up and say, this is the homepage of President Obama, and I can do that. At least given that this is still a free country, probably they'll leave me alone. Okay, but somebody else has to figure out that this page is not as good as the other glossy page at the White House. Okay, so anybody can make any page up, and so somehow the problems faced by the retrieval engine are higher now, because just because the words are present doesn't mean the page is equally good. Okay, so a page can advertise itself falsely just so it can be retrieved. Okay, and this ever since search became a relevant, interesting enough thing that people were doing, people have been doing this. False advertisement is the name of the game. So what this basically means is it throws a challenge. You sort of need, I think it's not important about the social structure, but the most important thing is you need not just picking relevance, pages which are relevant, but picking pages that are relevant and trustworthy, relevant and important. And I mentioned this, I believe, in the beginnings of the class, that relevance is something that you can actually, it's a local property. If you are looking for a particular set of words and I give you a document where those words don't occur, I better give you an explanation as to why I'm wasting your time with this document. If on the other hand you're looking for the home page of X, and I give you the home page of X, and it says home page of X, you didn't know that it's not the home page of X. Okay, so before itself, so the trustworthiness of the page has to be established before you even look at it. Because presumably you're looking for home page of, so all of you can, for example, generate home page of Rao Common Party right now, and then make up new homework deadlines, for example. Right? And I can't stop you. Okay, and then one of you who is out of, the few people who didn't show up to today's class, they will actually check one of these pages and say, oh, homework is no longer due, apparently. And then they'll follow that rule, and that's not going to be good, So they would not know that it's not right. Do you understand what I'm saying? So it's like they will look for the relevance. Is it a page about cse494? Yes, it is. Does it have the word Subbarao Common Party on it? Yes, it is, because you too can type find it. Okay? And does it look like it has something about homework deadline? Yes, it does. So I just assume it's true. So before this lay user looks at it, you should establish that it is actually the page, it's a trustworthy page. And so this is something that you did not have to do in IR. Now we are going to do this. The link analysis basically is one way of doing it, but in general you need page importance, page trustworthiness measures. And they should become part of your ranking. Okay, that's a big deal. And then finally, one other change I can think of, and you can probably write more things. Web users are basically lay users, unlike traditional IR users who essentially write paragraphs and and long Boolean queries and so on. And so they don't have any special training. They basically are ready to search. And they tend to typically submit short queries, very short queries. Okay, and but on the other hand, you have a really, really large user community. Okay, so this is actually, is it an opportunity or is it a problem? Is it a mixed blessing? Sort of a mixed blessing, right? Because you have a large user community, you can kind of do query logs and you can kind of use that to figure out what you might have been looking for. Or when you gave a keyword, I can suggest maybe you want to add these other keywords to your query. But the fact that the keyword queries are short essentially also means that you have imprecision built in even more than normal traditional IR. But on the other hand, people are not paying anything for this, so they're happy with anything they get. Okay, so overall it's a mixed blessing. Okay, so I still think of this as people are easily impressed. In general, you're more easily impressed, with a search engine because it's got something close and you're not paying anything for it. Okay, so these are things of these. Obviously, I will talk about this later, and I will talk about these two starting today. So essentially, using the structure of the web data to improve the retrieval, okay, and use the link structure to kind of assess page importance measures. Now it turns out page importance measures can be established in other ways, other than just link structure. But we'll look at that, and we will also on the side think of what other importance measures could come up. It is still worth noticing, I may actually be in a minority on this, but I think that relevance is different from importance. And I really believe that you can decide whether or not something is relevant when you look at it. But you would never know whether it is the answer that is the correct answer. Okay, so if you are asking for what is, I want to look for the gravity on Mars. I want to know what is the gravity on Mars, what is the gravitational acceleration on Mars. So you search for it, you get a page. Page made by this third grade kid. Gravity is on various planets, and it says Mars, some number. Do you know whether this is right or wrong? You have no idea. If you knew, then, unless you're one of those people who's testing web, and you have the answer and you're seeing how many pages have the correct answer, you don't know what the answer is. And you're hoping that I'll give you the answer by, you get the answer through the search, and in that case you can be in trouble if in fact, I didn't establish the importance of the page beforehand. Okay, so that's basically the issues that we're looking at, and in particular we'll look at these two. Okay. Now I did say web users tend to submit short queries. What I really want to say is they submit unthinking queries. Here is a query from from my query logs, on my search engine. And obviously, so there's an exception to the short queries. The students were looking for answers to their homework problems are willing to cut the entire homework problem and give it as a query to the search engine. Right? You know, it's like very important. I need to know it right now. And in fact, what's interesting is, as I've been teaching this course, I think in the first couple of offerings, actually, I could say that search engines, like, you know, most popular search engines have a limit. They would cut, words beyond 10 because they knew that nobody was searching for queries more than 10 words long. They would actually, even Google in its old instantiations would have a limit only of 10 words. So you put more than that and say, blah, 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 I'll remove it. Right now they don't do it. At least even if they do it, they don't tell you that they do it. They let you give it. Okay? So you can actually submit really, really long queries. Except most people, it's not like they really have thought through and this thing. This was just a cut and paste query. Okay?
So,
yes.
Do you have a search engine?
What?
Do you have a search engine?
I have quite an understand.
Do you have a search engine?
Do you have a search engine?
I have a search engine. No, I have my query logs.
Oh.
And I'm checking to see how many people are searching for homework solutions before they are put up. Right? So that's what I do, in my spare time. Anyway, but you can look at your query logs too. If in fact anybody is looking at your page, you can look at the query logs. It's like the total narcissistic trip. But anyway, okay. So the first thing I want to do in terms of using links and tags and metadata is that you can actually, so you can use tag information and you can use anchor tag information, for example. The two different kinds of tag information that you have on web pages. One is that you have basically a whole bunch of HTML tags, saying head, or the strong, the italics, or whatever, So you can assume that all flat text is kind of created okay. Anything in small font is sort of less important. Anything in huge big font is really important. Anything which is blinking is probably zero important because users will just go out of that page right away. But in general, the same word appearing, depending on the tag surrounding it, you can give it different levels of importance. Okay, so that's sort of, actually let me talk about that first and then come back to this. So in terms of the tag information, basically, you can look at it. This is one of the older ideas, for example. So somebody, for example, would have split the words in the web page into those that fall in title, those that fall in header, those that fall in on the list structure, with italics around italic tag, anchor, and plain. Okay. Now the interesting thing, of course, is and then so you count the words not as just a single. For each word, you don't just count one frequency. You basically separate the frequency into the frequency of this word in the title, the frequency of the word in the headers, the frequency of the word, in the list, and so on. Okay, and then you basically compute the effective frequency by giving higher weight to things that you think humans will give more importance to. And if something is in big font, we tend to give more importance to it. Okay, and if it's a small font, we tend to give less importance to it. Okay, so you can perhaps do that. You can do this. So the term so you can actually have like a 6-array weight vector, W1 to W6, and if it's 111, that basically means you don't give any special importance to any tags. If you put higher numbers for some of them, then that means you're giving higher importance. Okay, now and of course once you have that, if you have each word's term frequency itself is a vector, and you take the dot product of these two vectors, you get the effective term frequency, which is basically in this case dot product is being used to get a weighted sum. That's simple enough. There's nothing huge about it, but it's worth doing clearly because a word occurring in the header should mean, so if you have two pages, right, in one page the query words occur in the header, in the other page the query words occur in the footer or maybe in the middle of the text, then I'm going to say that page is somehow more relevant than this page for this query. And it seems like a reasonable thing to say. Okay, simple enough idea. In terms of the weights, they can either be preset or you can actually learn if you're serious about splitting hairs. You can try to figure out what's the optimal weights for these. Now to learn that, then you actually have to see for each weight vector, that you're trying, you have to actually do controlled experimentation to see whether more people are finding the results to be more relevant with this weight vector as against this other weight vector. Okay, these are the famous A/B studies. Essentially, you have two weight vectors, and so the search engine can show for some number of people, the results using one weight vector. The other number of people, results using a different weight vector, and see, overall which users seem to be hanging around in the first page, and which of them seem to be going to the second page. If you go to the second page, from a search engine point of view, they lost the business, right? So that's one way you can actually learn these two. But as far as I'm concerned, you can put a reasonable number of reasonable weights. Clearly, you can tell that title and header should probably have higher weights than plain. Okay. How about list and strong too? But how about anchor? So the anchor text basically, I assume that all of you know anchors, HTML anchors. So basically, when you are about to send a link, then you put, some text around that link, and that would be shown in nice ugly blue, and that's basically sort of describing what this link is supposed to be. Right? Now, of course, this was the old way. Nowadays, people actually just say, they'll put the link in some color, just a dot, and then there's text around it. Okay, so there are two ways of defining anchor. One, of course, is to actually see what is in that href, tag. Okay. The other is if ahref tag happens to be null, that means there is no text there. Okay, then you can see with respect to that link some number of keywords on this side, keywords on that side. That window around the link, and take that window to be the implicit anchor, because presumably you said something about the link right around the place where you put the link.
Yeah, but the relevance should be counted not for the page that contains the anchor, but for the page pointed by the anchor, right?
That's the next point I'm going to say, which is essentially when you have anchor, then it not only affects you because you have this text in your page, but it also sort of is a description of some other page. Okay, so in fact, anchor text is the way you essentially tar other pages or change the contents of other pages without actually breaking into the accounts, right? So all you need to do is, if all of you, now have one less person because he just walked out, but the rest of you essentially put a link, to my page and make up, decide what text you're going to agree on, then basically that text becomes pretty important part of my page.
Why don't we do the experiment?
You can do that, right? And then, and then I can also basically decide what grade should be given to the class. But that's so, but the point is,
that was a test of it.
yeah. So, but the point is that you can change the contents of another page by just putting links to it. And this is a very, we talked about this in the beginning of the class, and you probably are aware of it. It's become, part of the popular culture already. But the important thing is, if this page has some number of words, and then these words are occurring in the pointers to this page, should these, in some sense, these words now are part of this page's content. First thing that should blow your mind is that your content is not yours anymore. Your content is a summation of whatever you have, the union of whatever you have, plus all the words in the pages that are in the links that point to your page. That's also part of your content now. Okay? So in fact, content itself is non-local. Okay. Secondly, should these words have, higher or lower weight than the plain words in my page? That's an important question too. So do you want the text in the hyperlinks, the anchor text pointing to this page, should it be considered to be more important than or less important than the text in this page? And once again, we talked about this. The basic idea is it matters more as to what the world thinks of you than what you think of yourself. For you it matters what you think of yourself. Okay, but for me it matters what the world thinks of you. Because if I'm searching, who is the most prolific author, then, and if you just allow people to, make generic, statements, they will all say they are the most prolific author, the most beautiful people, whatever. And so it does matter what the other pages are saying. So in general, while you can come up with like some sort of a counterexample to this in specific cases, you do essentially give higher weight to the anchor text. Now, of course, that can be used for good and for bad. Every week you see new articles which essentially, this is, first of all, this is not a new thing. It always, even before we had computers and hyperlink, the gossiping about other people does change the other people's lives. And, people were always aware of it. If you're all gossiping saying that person, man, is like so good in some good way, then, that will change their life in a good way. If you put them down, it will change their life in a bad way, right? It's been around before, except now we can actually put these links. And in fact, New York Times this week, I believe, either on Monday or so, had a front page article saying small town gossip is now, in the old days, the way you would gossip is you'll go to some little diner and sit around and then talk about the people who are not at the table. That's basically the whole point of being a human. Talking about people around the table is no good. Okay, so we used to go to a diner, and so diners used to actually do well. Now, even in small towns, apparently people don't go to diners. And so they instead just sit in front of their Facebook page and, just send comments about other people. Could you believe? And in fact, New York Times had all these, nice little quotes of people, saying reasonably mean things, mean being actually a kind word to what they're saying, about other people. Okay, so the anchor text the societal anchor text has already gone online. But even in the web pages, the anchor text does tell you about what other pages think about this page. Okay, and so it should have higher weightage. But what that also means is, of course, this is the famous example. So there was a time, it no longer is happening right now, but if you search for miserable failure, the front of the page, the first link would be President of the United States. Okay, and is it because the President of the United States told his staff, please put the word miserable failure in big header on my page? Of course not. We elect our presidents with little more thought than that. Okay, supposedly. But in this case, what happened? Enough people put a link to White House page and said, for a miserable failure, go there, right? And enough people put it, and that basically for the miserable failure, the first link was actually White House page. Okay, and then of course Google was in this business of we do not touch our search results. This was still at the time when they were saying we do not at all doctor our search results. So we will leave President to be the miserable failure. We'll put a link saying why are these results coming, where they will give you an IR lecture. There is this thing called anchor text, and that's the reason, and if we actually don't show it to you, you'll get mad at us. That some other people will, algorithm police will catch us. Okay, and this was, some years back. And actually, after Obama presidency, again, there was another incident of this. Some of you probably are aware of this. I think somebody essentially did enough links so that if you said some monkey something, then Michelle Obama's page will come up. By this time, essentially, Google just banned that page. Because, by this time, the societal, understanding of whether or not it's okay to give anchor text-based lectures to search engine users has taken a different turn. So they just banned that page, once it came up. Okay. Anyway, so that's what that one was saying, and in fact, yeah. Anyway, so I think this one was only showing that after some time, it slowly went away, and then basically the only way you could see this is BBC News article saying it used to happen at one time. Okay, you can still do this, essentially, at least for a certain amount of time. And after that, then people will, probably change the search engine can change the index. They set those numbers, the anchor text numbers. It's not necessary that everybody should have the same numbers. They can decide whatever they want to do. And so if there is a particularly offensive thing that's coming up, and then you can, you can play with that and remove that. Okay, but the point is, this is to be expected because other pages can change what you stand for. Okay, the good side of this is what I mentioned some time back, which is the original Netscape page didn't have the word browser on it, and yet browser is like the most important word that describes the Netscape page. So other people were saying browser, browser, browser. And so you could still get the Netscape page. And even now that is true. In general, a page itself might not have thought about writing some words in its content, but other people are saying, here are some words that are important in understanding the content of this page. Okay, so you can tar someone's page just by linking to them with some damning anchor text, and if the anchor text is unique enough, and this is my little blurb on how you can do a Google bomb yourself. At least you probably stay for a day if you can do it quickly. Just if it's, again, this is just figuring out how things work, okay? If the text that you're putting is unique enough, then even a few pages linking with that in the keyword, in the anchor text, would be enough to bring that page as the result to that text. Okay, what's surprising here is miserable failure is a pretty common 2 keywords. And to tar somebody with miserable failure, you need the entire Democratic Party working full time. I mean, my own understanding of why, the 2004 election went the way it went is because all the Democrats were busy making links instead of actually going to the election booths and, casting votes. But anyway, so this is pretty impressive because it's a common word, and for a common word to become owned by you, lots and lots of people have to say that about you. Okay, if you want an uncommon word, here is my cuddly bubbly woogums, and you can write this in an anchor text and then point to whoever is your cuddly bubbly woogums. Okay, and the world, if in fact searches, if it ever searches for that word, will get that page. Okay. Now, of course, impersonation movie is already taken by Seinfeld, in case you know that Seinfeld episode. But for the more commonplace keywords, you need many more people doing this. So the only good thing about my cuddly bubbly woogums is the first time when I wrote this slide, we said my cuddly bubbly woogums. It says your search, my cuddly bubbly woogums, did not match any document. Bingo! That's all I wanted. Right? Because I wanted a phrase that doesn't occur anywhere else. Then if just 3 people use this, I mean if I just make 3 fake pages and point to my cuddly bubbly woogums with that, then that person's page will come up. That particular page will come up as the answer to this. Okay. Apparently I'm still ahead of the game. Before coming to the class, I did this, my cuddly bubbly woogums again, and there are 6 pages in the entire world which have this, and they're all my class pages or copies of my class pages. So it's still, you can still use it, and have somebody's page. Anyway, so the point, the technical point you want to understand is, if this word, this phrase is common enough, then you need lots and lots of people to use it in the anchor text. For that to become, for this particular page to kind of own those words. If in this case, there is no competition for being my cuddly bubbly woogums, apparently. And so, whoever I say it is, they will become that. Okay. Okay, so that's the easy part, which is basically how to use the tag structure. And I think of those, one was very simple, basically use the weight vectors. The other is slightly more interesting, which is using the anchor text. An anchor text actually does bring up this whole point that the contents of a page are actually non-local. Because you get indexed not by just yourself, but by what other people say of you. How many of you have seen a search engine result where when you actually clicked, it said the words only appeared in links pointing to this page, but not on the page itself? If you didn't, what can I do? I mean, I've seen it lots and lots of times.
We have seen, because when you control it and try to find that word, the search within that page doesn't.
It won't be there. And then, in fact, actually in the cache, the Google search engine, for example, in the cached version, they will even show that the word only appears in the links pointing to it. It's not there in there. Because In a cache, they're supposed to show in yellow, the words. And if there are no yellows, then they can realize that either they totally messed up their indexing, or it must have been in the links pointing to this. And so they just say it was only in the links pointing to it. Then you can ask, who are these people who are saying these kinds of things about me? And then you will get their URLs, but that's a different story. Okay, so the second thing I'm going to talk about, which will take, starts today and goes to full up next class, and it is essentially dealing with the uncurated adversarial nature of the web by sort of establishing page importance measures. And as I said, page relevance and page importance both have to be taken into account in actually deciding to show results to the users. Because just because the words are present in a page doesn't necessarily mean that that page is actually the representative of those words. Because anybody can make any page. You see? Okay? So, pure query similarity. So this is basically just sort of summarizing whatever I've been saying in the background. Pure query similarity will be unable to pinpoint right pages because of the sheer volume of the pages, because anybody can put any words on their pages, essentially. Okay? So in particular, so there is this idea that even if your page is 1 in a million, if there are like 8 billion pages,